My dear friends, there is a question given here based on prime numbers. The question goes something like this: if p is a prime number greater than 3, then p square minus 1 is exactly divisible by dash. P square minus 1 is exactly divisible by dash. So the given options are 11, 12, 13 and 14. The options are very close. So as we have learned in the previous video, so the first rule that we are going to use to solve this problem is any prime number, if p is taken as a prime number, any prime number, if it is greater than 3, if prime number p is greater than 3, that means starting from 5, 7, 11, 13, etc. So that prime number, that p should be in the form of 6n plus or minus 1. That prime number should be in the, if you are claiming a number greater than 3, if you are claiming a number to be a prime number, that prime number should be in the form of 6n plus or minus 1. So I am using this rule and I am writing p square minus 1, that means 6n plus or minus 1 whole square minus 1. And now I am using the formula, I am expanding the formula, a square, that means 36n square. So plus or minus 2 into 6, 12, 12n plus 1 and minus 1. After the bracket there is minus 1. So plus 1 and minus 1 gets cancelled. So I am taking 12 as common here. So 3n square plus or minus n. So clearly we can see here 12 is coming as a multiple. 12 is coming. Obviously when it is divisible by 12, it should be divisible by its factors also. 6, 2, 3, etc., 4, etc. Okay, fine. But here it is divisible by 12. So based on the options given, so it should be exactly divisible by 12. 12 is the correct answer for this question, and obviously it will be divisible by its factors also. So 12 is the correct answer. So what is the rule that we have used? Any prime number greater than 3 can be written in the form of 6n plus or minus 1, where n is a natural number. Friends, here there is a question given on prime numbers. If x, y, z are prime numbers and x plus y plus z is equal to 38, then what is the maximum value of x? X should be maximum value. The options given are 38, 37, 36 and 31. Obviously 38 is not the option. From there only I can, 38 is not the option, because if x is equal to 38, the other two numbers will become 0, and 0 is not there in prime or composite family. So we will see from 37, 36 or 31, something should be the answer. Clearly, my dear friends, x plus y plus z is equal to 38. The sum is fixed and he is telling x should be as maximum as possible. X should be as maximum as possible. That means y plus z should be as minimum as possible. Y plus z should be as minimum as possible. So this question is given to you, remind you that what is the minimum possible prime number, that is 2. 2 is the first prime number and it is also the, obviously it is also the least prime number. So both the values I will take it as 2, and then the value of x will be 34, so that the sum is always fixed. Friends, yes, this sum is taken as 4 and this is 34. 34 is not a prime number. 34 is not a prime number. So we'll compromise a bit and we'll make this a little bit higher, this sum a little bit higher. So what is the next possible sum that we can make? 3 plus 2, 5 I can make, and this will become 33. Then the sum will be 38. No, 33 is also not possible, because 33 is also not a prime number. Then I am going for the next possible sum. I am going for 3 in both the cases, 32. So 32 is also not a prime number. So I have tested this y plus z making sum as 4. I tested by making this sum 5 by 6. Now I am going to make next possible sum, that is 5 plus 2, because then the sum will be 7 and this number will be 31. Yes, 31 is a prime number. 31 is a prime number. So 31 should be the maximum possible value, because I have tested with 34, 33, 32, one by one I am coming. So 31 is the only number, then the sum will be equal to 38. So maximum value that I can, in this equation, the maximum value, if all x and y, z are prime numbers, see, you can see every number is a prime number, but to make this sum possible, the maximum value that I can take x is 31. So this question is simply to remind you that the least possible number and the least possible prime number and the first prime number, or the only even prime number, is 2. So particularly this question is designed to remind you the importance of 2 in the prime family. Friends, let us have a look at this question. Let x be a 4-digit positive integer. Positive integer. Positive integer means natural number. Let x be a 4-digit positive integer such that units digit of that x. So whatever that suppose that 4-digit number is a, b, c, d. This is the 4-digit number. Digits I am taking as a, b, c, d. Such that the unit digit of that x is prime. This number is prime. This digit is prime. And the product of all the digits, is also prime. The product of all the digits is also prime. Okay, how many such integers are possible? Friends, before going for the solution of this question, the simple point is, if the product of two or more numbers, if somebody is saying x into y is equal to prime, x into y is equal to prime, the product of two numbers is prime. Okay, so obviously, what is a prime number? Prime number is such a number which doesn't have any factors except one and itself. Okay, so one of these numbers should be prime, this number or this number, and other number should be 1. Or this number should be prime, or this number should be 1. This is not only valid for two numbers, for any kind of numbers. So x into y into z, three numbers, whatever it is, they are saying the result is a prime number, the product is a prime number. So obviously 1 will be prime. Only one number will be prime and the remaining numbers will be 1. So prime, this will be, x can be a prime number, then these two numbers will be 1. If y is a prime number, these two numbers will be 1. If z is a prime number, these two numbers will be 1. That means if anyone is saying the product of two or more numbers is 1, then definitely one number will be a prime number, remaining all the numbers will be digit ones. Okay, because this is a common sense point, because prime number is such a number which is having no factors except 1 and itself. So itself should be there obviously, and remaining numbers will be 1, because if you write any other number, that will not become a prime number, that will become a composite number. So in that way it goes. Okay, now let us go into the solution of the question. Now they are saying that a, b, c, d, this is x, this number is x, and they are saying ABCD is a x is a 4-digit number, that let the digits be ABCD. So and their product a into b into c into d is prime number. And not only that, d is also prime number. D is also the units digit, d is also prime number. Obviously, he said where the prime number is located. So we know that if the product of, here digits we are taking and this whole number we are calling it as x. But the point is the product of two or more numbers. The product of two or more numbers, if it is a prime number, definitely one number is prime and the remaining numbers will be 1. Okay, so already we know where the prime is located. This is the prime number. So obviously the remaining numbers, a must be 1, b must be 1 and c also must be 1. And now you tell me d is a single digit number. How many single digit prime numbers are there? 2 can be there, 3 can be there, 5 can be there, and 7 can be there. That's all, because d is a single digit number. So there are only 4 single digit prime numbers. What are they? 2, 3, 5, 7. That means the combination can be 1 into 1 into 1 into 2. Similarly 1 into 1 into 1 into 3. Or 1 into 1 into 1 into 5, that 5 and the last number is 7, 7 is also prime number, 1 into 1 into 1 into 7. So there can be 4 numbers possible, like this, 4 positive integers. Positive integers means nothing but natural numbers. Okay, there can be 4 values possible if d is a prime number, x is a 4-digit number and unit digit is a prime number and the product is also prime number. So single digit prime numbers are only 4. So obviously option A, 4 is the right answer for this question. Friends, let us have a look at this question which is based on prime numbers. Find the value of n if n square minus 14n plus 24 is a prime number. So this whole number is a prime number and he is asking what is the value of n. Okay, the options given are 13, 11, 17 and 23. Now friends, here we will factorize that quadratic expression. So n square minus 14n plus 24. So I can clearly write it as n square minus 12n minus 2n plus 24. So if I take n common here, so I will get n minus 12, and if I take minus 2 common here, then also I will get, I will get n minus 12. So that means n minus 2 into n minus 12, n minus 12. Okay, so I factorized this quadratic expression called n square minus 14n plus 24. So I got the factors as n minus 2 into n minus 12. Now coming to this actual point, he is saying that this whole expression is a prime number, and this whole expression is a prime number, and this expression came as two numbers, that is n minus 2 and n minus 12, n minus 2 and n minus 12. And if you multiply this, obviously that should be a prime number. He himself gave in the question that this is a prime number. So this is a number, this is a factor we got, this is a factor we got. We know very well, just now we learned, we know very well, if a product of two numbers or more than two numbers is a prime number, one digit will be, in that one number will be prime number, remaining all the numbers will be 1. That means, my dear friends, either n minus 2 should be equal to 1 or n minus 12 should be equal to 1. If n minus 2 is equal to 1, the value of n will be 3. If n minus 12 is equal to 1, the value of n is equal to 13. The value of n is equal to 13. Now let us take both the cases. If n is equal to 3, if n is equal to 3, my dear friends, if n is equal to 3, and here 1 into, so I am substituting here 1 into 3 minus 12 and 1 into minus 9, this is a negative number. So this is not possible. So if n is equal to 13, so we can take like this, 13 minus 2 into 13 minus 12. So 11 into 1 is equal to 11. Yes, 11 is a prime number. 11 is a prime number which is there in the options. So here if you take, sir, what happens if minus prime number, negative prime number मान सकते ना, but 9 is not a prime number na basically. But 9 is not a prime number. So negative or positive 9 is also not a prime number. So 11 is a prime number. So obviously n minus 12 is equal to 1. Logic should be true. And what is the value of L? What must be the value of n? The value of n must be 11. So B, option B is the correct answer for this question.